So now that we're all friends, and you've seen me diddle around with my machine, I'm just going to cut right to the chase and kind of be a bit straight up. I think building front-end JavaScript applications is pretty damn hard. And I think there are a bunch of factors that contribute to this, and one of those factors is that they're just giant balls of state, which is what Pete was talking about. So I thought it would be kind of interesting to take a bit of a step back and maybe play the devil's advocate and take a critical look at some of the patterns that we see being applied on front-end JavaScript code bases and see if they give us ways of handling state and events in a scalable and maintainable fashion. And then maybe we'll take a look at some of the tactics that we can use to help us better embrace state and events without sacrificing clarity in our architecture. So I'll just introduce myself. That's not me. I'm Amy. I've come from New Zealand. If you're ever in Wellington and you want to hang out, just give me a shout on Twitter. I'm a meep. And as Jared said, that I work at GitHub. If you want some stickers, my buddy Marcus is down the front. He's got a whole pile of them. Direct all of your attention that way. I've also got a tiny confession. I don't write any JavaScript at GitHub. I build the GitHub for Windows client, so I'm a Windows developer. I'm actually pretty new to GitHub, and before that I was writing a whole ton of JavaScript, building apps in Backbone. So in terms of architecture, front-end apps have actually quite a bit in common with desktop applications, and the thing that ties them together is that they have heaps and heaps of state. So front-end JavaScript apps contain lots of different kinds of state. They've got the state of the core entities, our models. They've got that state that needs to be kept in sync with the server. We've got the state of the address bar. We've got the state of all the different views that are presenting various bits of information on the screen at any given point in time. And then we've got the overall state of our application, memory management, all of those kinds of things. So on its own, state isn't very interesting. What makes an application interesting is the interaction with that state. So if we're able to interact with the state and force new transitions, new states on the system, then suddenly we have something that's way more compelling. So traditionally, state transitions are going to occur via events. So for example, you've got some data on the screen, a text box, somebody enters some information, they click save, the model gets updated, and we transition into a new state. It might be an invalid state. So the thing about these heavy-duty, thick client JavaScript apps is they're basically these blobs of code that kind of just sit there and wait for interesting things to happen. And we have a bunch of ways that we can make interesting things happen. So we've got DOM events, which are like click, drag, key out, there's a whole pile of them. And we've got model events, so that might be when we transition into that invalid state, our model might raise a signal to say, hey, I'm actually in an invalid state, and people who are interested in that will be subscribed to those events. We've also got routing events, so these are kicked off when the address bar changes, and we need to do interesting things to the overall view state of our application. So we've got lots of state, and we've got lots of events, and they all need to be managed. And if we don't manage them in a way that kind of accurately separates all of the concerns out, and state and events, they're going to get really tough to manage. So I've got a really contrived example here of state and events being managed in a pretty suboptimal way. So we've got a view. It's a party view. There's just one lone party animal at the party dog, and we're going to have an invitation list as well. So here we can input a new animal we want to invite to the party, and we've got a button with an on-click handler. Shout out, awesome. So please don't do this. And so when somebody clicks that button to invite the animal, we're going to use jQuery to reach into the DOM to grab the state of the text box. We're going to pull that bit of information out. We're going to invite that animal to the party. We're going to build up a new view. We're going to reach back into the DOM and put that in there. We're doing a whole pile of, it's spaghetti code, basically. So if you're going to extrapolate that kind of code to its natural conclusion, it's easy to see that we've got state and state changes, state and state transitions being intertwined. And we're very quickly going to end up with an unmaintainable code base. So the more state you have, the harder it is to manipulate state, and the trickier it all becomes to manage. And so this is where people are going, hey, we've got design patterns, and that's awesome, we totally do. They've come to save our souls. So the thing that I find really interesting about design patterns is I contrast to what's going on in the physical world of engineering to what's going on in the software world of engineering. Physical engineers are going to build buildings like this, and they have a specific way that they need to construct the building so that it doesn't kind of collapse and kill everybody inside. And they're going to need to do that regardless of the outcome of the building, whether it's going to be a meat market or whatever. But in software, we kind of have these these looser ideas that we can apply in very different contexts. So, I mean, I guess because we're not bound by the laws of physics to a point. So it's interesting because it means that we can take patterns that have been applied in very, very different contexts and start applying them to help us solve interesting problems in new contexts. And it means those ideas kind of evolve a little bit like memes on the internet, right? Like meme actually means anything that's spread or inherited in a non-genetic fashion, which basically means memes are ideas. So they're ideas that stick because they're funny or because everyone thinks that they contain an interesting solution to a tricky problem. And I think that the MV star family of patterns is an example of this. So originally, presentation patterns that fall under this category, they actually originated from building desktop clients. And then over time, web and web server programming became really popular, and these presentation patterns were applied in that context. So we end up with web server frameworks like Rails, which are implementations of MVC, and then we've got these kick-ass front-end JavaScript frameworks, which are also claiming to be implementations of an MVC pattern. And I really don't want to turn this into a conversation about like who's doing MVC by the book, because that's not particularly interesting. But what is interesting is to take a look at how each of those flavors are being applied in the different contexts and how they affect how we manage state and how we manage state transitions. So I'm going to take a quick look at how we manage state and the web server environment. So hopefully some of this is going to be mostly a reminder. So we've got models. They are the guts of our application. That's where all of the interesting domain logic is going to occur. We've got views, and they're the presentation of those models. And typically this is going to be like a JSON document or an HTML document. So the interesting thing about views in this context is that they are a snapshot of the model's current state. And then we have controllers, which are responsible for sending commands down to the model. Maybe they will transition the model into a new state, persist that back, maybe just query it, and then they're going to return a snapshot of that current state, a representation of that current state. And then we have routers. So they're responsible for doing some pattern matching of an incoming web request, routing that off to a designated controller, and then to an action, which is the action selection is normally done with a combination of the URL that's come in and the HTTP verb that's being used. So how does this relate to how state is managed on the web server environment? Well, hopefully you're all going, what are you talking about? We don't have state on the web server environment. We want to be stateless because we want to be able to scale our applications. So how are we achieving this statelessness? Well, we're persisting our models to a data store of some kind. And so in this environment where state is persisted to a data store and we're able to address that state via HTTP, like we can say, HTTP, get me all the animals at the party. And then if we find out one of the animals is causing a bit of a commotion and we want to kick him out, we can just execute an HTTP delete against that same resource. So what we've essentially done here is we've simulated a state transition across the HTTP boundary, across the client-server boundary. And what that means is all states and all state transitions are necessarily addressable via HTTP. So a quick example, we've got a couple of routes here that we're defining against the same party resource, get, post, and delete. The get example is going to take the incoming parameter, it's going to go to the data store and find the particular animal and return a snapshot of that current state. We're going to add an animal to the party, we're going to grab that incoming parameter again, we're going to modify the state, persist that down to the data store, and then return a new snapshot of the party's state with an extra attendee. And the same goes for the delete when we want to kick somebody out. We're going to modify the state of the party, persist that back to the data store, and then return a new snapshot. So routers are matching a web request pattern. It's handing it off to a controller and invoking an action who's going to do a model lookup and an update and return a snapshot of the new view. So because of that client-server boundary, all of the states and all of our interesting events are addressable via HTTP. And the way that we use routes means that our architecture is very linear. So requests come in, something may or may not happen to change the model state, and a snapshot is returned. So we've gone down the stack and up the stack again. So the key difference for the way that we implement MVC on the server and the way that we're going to implement MVC on the client is that the implementation on the client has a lot of state. We don't need to try super hard to be stateless anymore. In fact, we want to embrace state. So we're keeping a bunch of things in memory here to form a cohesive application, and it all comes together to form a very rich and non-linear state space. We've got our models. They're usually coupled with a snapshot that's coming back from a server, that JSON document that might come back. And then we add an extra layer of complexity on top of that. We've got validation, security, we're applying new behaviors through other functions. We've got to decide when we keep that state in sync with the server, so we're keeping that in mind at all times. The number of possible states that we've just put on top of that snapshot has blown out proportionally. On the screen at any one time, we've got many different views that are each presenting different model states. And together, those views define the overall view state. So what menu items can we see in the sidebar? Like, are we able to edit the party and kick somebody out? Are we able to invite a new animal to the party? And are we even able to see what's going on, the shenanigans going on inside this party? So this is adding again to the complexity that we have in the state space. And overall, we've got the overall application state as well. So this is things like which modules and controllers are currently active and which ones are no longer active and should be cleaned up in order to free up that memory that we are hogging. And of course, that state boundary that we had on the server, that client-server boundary, is no longer relevant. Suddenly, we don't have to emulate state transitions across a boundary. State and the transitions occur within the same execution context, which is awesome because it means we have a much, much richer set of concepts that we can architect our application around. So as the state space grows and we're moving around this state space in a very non-linear fashion, things get complicated really, really quickly. It has a dimensionality to the problem which makes managing all of this really, really tricky. So we need to have a plan. We need to apply some memes, some ideas, some patterns to help us out here and not end up in a spaghetti code soup. So we originally brought over these presentation patterns onto the client to help us deal with complexity, the complexity that we saw on the client. We've got models, we've got our views and our controllers, these concepts that we saw on the server. I mean, whatever you want to call that controller part, I have weird feelings about that name. And then we've got routes, okay? And we add those to the equation so that we can address parts of our state space. So I look at this and I think, this is a little weird. Like, why do we have routes here? Like, on the server, the purpose that they served was that we needed to be able to address all of the transitions and all of the states. And here, we don't really need to do that. And then I remember, okay, it's actually not weird at all because we still need to be able to address parts of that state space. We absolutely need to be able to take the URL in the address bar and give that to your friend and have them see exactly the same state on the web page. So addressability and the support of routes is still a really key part of our design. So let's take a little look at the typical way that we might structure some of our client-side code to account for the need to be able to address all parts of the state space. So I'm going to give this example in Backbone. So we've got an animal and a collection of partying animals. We've got a party view which has a template and a render function. And what it's going to do is it's going to take the template, it's going to take the model, and it's going to mash them together and spit something out onto the view. And then we've got our app router. And we're defining a couple of routes here. We can start the party and turn the music on and let them go. And we can also uninvite any misbehaving people. So we're going to revoke party rights. What we're doing here is we're taking an incoming parameter from the URL, we're grabbing that collection, we are finding the animal in the collection, we're destroying the model, and then we're reaching back into the DOM to remove the view. And in the starting the party case, it's very similar. We're creating a view, doing a fetch and a render. So what's going on here? We're breaking encapsulation to push everything up into the routing portion of our code. So we've got this view controller thing that's responsible for doing some initial rendering. And then when it's got a reference to our model, and then the route kicks off. And the first thing that it does an active lookup for the model. So we've got these stateful concepts where our view already has a reference to the model, but we're going to grab the collection and do a lookup anyway. Okay, that's fine. And then we're going to perform an action against that model, and we're going to transition it into a new state. And then the next thing we need to do is deal with some view concerns. but i.e. we need to remove that view from the screen. So again, we're breaking encapsulation here. The view controller thing already has a reference to the DOM element. Why are we creating the spaghetti code in the router? Why wouldn't we just let the view be in charge? Over time, that's going to become very difficult to maintain over time. So on the client side, we're often working with these heavily stateful frameworks, and all of the objects that we need in order to perform a state transition, they're already instantiated and already held in memory. We don't need to structure our application in the same way as we were on the server, because on the client we can fully embrace state. We don't need to manipulate our models like they are rows in a database. Our models can be rich, interactive, real objects. So we took these ideas, these flavors of MVC that we saw on the server, and we tried to apply that very linear approach to the client, and we started to break encapsulation pretty quickly in order to hinge our application around the design and the need to support routes. We started to treat state and events and the very things that give us that rich interactivity on the client side, we started to treat that like a second-class citizen. At the start of the talk, I showed you that awful jQuery madness, where we were doing weird things like triggering events from the DOM and then reaching into the DOM to grab the state and then persisting that state back into the DOM, and it was all kind of crazy. We were executing that state transition to update the DOM and show the new state. And that code doesn't scale very well beyond a very simple use case. And the reason is because it breaks encapsulation. And I kind of feel like we're back at this again. We're using routes heavily because they're convenient. But in doing this, we're sacrificing clarity in our architecture. So to build accessible single-page JavaScript apps, we still need to use routes. And it's critical that we're able to address portions of the state space. But in my mind, routes are a feature. They're not the cornerstone of our architecture. The cornerstone of our design and our architecture should really be concerned with state and events. So are routes the problem here? I don't think routes are the problem here. I think the thing that's causing us pain is only using routes as the part of the architecture, breaking that encapsulation of the views and the models in order to get it done as quickly as possible. It's not giving us a way to scale our design. So separating concerns, as we've seen, is super important. We've implemented that MVC design pattern on the client in the first place to get rid of all of that tangled mess. But somewhere in the course of doing that, we've too closely emulated the designs that we see on the server, the things that work really well for stateless web applications. And as the complexity grows in our very stateful application, we start to see the cracks in that approach. So thankfully, I think we can find a happy medium where we can embrace the need for routes on the client without relying on them to drive state and state changes within our application. We can use events and a composable architecture to help us separate out our concerns. So let's first take a look at the bloated router code example that I gave. Hopefully it should start to be apparent that addressing a state transition like a delete is probably not the best thing to do in this case. So we've still got our models. We've got our animal model and our party animal collection. We've got a party animal view, which as before has a template, but now it has an event hash, which is cool because it means that this view is now listening for click events on a link, and it's going to route that down to a delete function. That delete function is able to say, hey, I'm just going to delete the model that I have a reference to, and then I'm going to close myself, which is so much more simpler than looking up a model and reaching into the DOM and removing that from the DOM. It's kind of, the concerns are way more encapsulated in this case. So as I say, we don't need to do that unnecessary lookup anymore. And we're also using declarative events, so we can bind the delete link to the delete function on the view. And it allows us to call destroy on the model directly, which is a huge one. And for bonus points, we're letting the view take care of itself. So that's fine, but I said earlier that routing is still a key part of the client-side code, and we need to support this feature of addressability and some of the state space. Our application is going to suck if we don't do this. We need to be able to give those URLs to our friends so that they can arrive at the same state that we did. So how can we better embrace the need for an event-rich, MV, whatever you want to call it, pattern, and the need for routes in a clear architecture? So I just want to show you a couple of ideas, I guess memes, and you guys can apply them in whichever way you choose as appropriate. So we're going to take those models, those rich objects, those views which are responsible for rendering templates, and then the views mediating any interaction between the template and, the DOM and translating that back down to the model. And we've got a controller object which is responsible for keeping track of those models and views. We're going to take all of those and we're going to put them into a single component, logical component, a module. So a module is responsible for coordinating all of the state and events that we have at a very micro level. So we're not talking a one-to-one relationship here. We're talking about many views, many models, all aggregated within a module because they are related to each other on some level of functionality. So it's a discrete area of, a discrete functional unit, I guess you could say. So those modules are free to present views and raise events within themselves and keep track of their own internal state. So just to briefly note that while these models are kind of, modules are free to present their views, I don't think they should be directly free to start placing themselves on the DOM because then you're coupling those modules to the state of the DOM at any given time. So rather what should happen is we should delegate that responsibility to another component or another component responsible for making the choice of how our overall view state is going to be composed. And so this is going to be the job of some kind of layout manager thing. Naming things is hard. Its responsibility is going to be to compose the UI. So the layout manager is going to define a top-level view, a shell, and it's going to have areas that the modules are able to render within. So like a sidebar, footer, main content region. And when a new module is activated, the layout manager is going to be responsible for swapping out existing views with the new views that this module is presenting. So internally, the module can figure out which controller and which view and all of that kind of stuff needs to be presented, but the layout manager is responsible for that composition. So it's going to look a little bit like this. We've got a bunch of modules presenting micro views and a layout composer working out how they all work together, responsible for composing that UI. So this placement is going to occur when a new module is activated. How does that work? So the thing I think should be responsible for this is for giving the modules to the layout manager is some kind of dispatcher object. It's going to listen for interesting events which indicate that a new module needs to be invoked. And when it receives these interesting events, it's going to load the target module, it's going to instantiate it, and it's going to give it to the layout manager, who will then in turn compose the application shell. So one of the interesting events that this dispatcher object thing might listen to are our routes. So a routing event might fire, and the router is going to facilitate the mapping between a URL and a module, or even a collection of modules. It's responsible for observing on and acting on URL changes, but it doesn't actually do anything with it other than say, hey, the route's changed and these are the modules that I know you need to invoke now. It's going to delegate over to the dispatcher, and the really cool thing about this is it means that other events have the opportunity to be raised and signal to the dispatcher that new modules should be loaded. We're not hinging our design around route changes. Route changes kind of sit on the side as a feature. And then the last thing that we have is the Bootstrap of our application. So this is the entry point and the exit point of our application, and it's responsible for composing the top level architecture that we've kind of got going on here. And it also acts as an extension point for your lifecycle. So we've split up some of those concerns that we had around state and events, and all the many views that we were displaying at any given point in time, and the state of the address bar. We've come up with a much more composable design where we're using events to transition into new states in a non-linear fashion. So I've actually gone really quick. So if that was too long and you didn't read it because reasons, I'll sum it up for you. So the management of our state space gets really hard when we don't separate our concerns, when the complexity starts to blow out. On the client, we should be using routes to address state, but never state transitions. And we should be taking ideas from one context from another and applying them and taking inspiration from the server. That's great. That's how new ideas form. But if we're not careful and we treat this like a rule book, we start to apply patterns that work well for a linear architecture in a state space where it's non-linear and the cracks start to show. So we need to mold these ideas to support the new requirements, the requirement to be stateful. So we need to embrace events within the same execution context, and we don't want to bake everything into our router. We need to make sure that we're architecting our client-side code less like it's a web server, because let's face it, it's not a web server. And that's all I have to say. Thank you.